download this.
Yep.
All right, for each polynomial, state those following things. Well, let's start with 1, the degree.
Okay.
What's the degree of number 1?
It's cubed, so would it be 3?
Okay.
Or would it be cubed?
No, it's 3 is the degree. Number 2, the degree is what?
Number 2 is 4.
Okay. I'm trying to think if it makes more sense to do each one of these while we're doing it. Yeah, I think it might. Without graphing, find the end behavior of number 1.
So number 1 is gonna be down, or it's gonna go up to the right and down to the left, or no, up to the left, down to the right.
Okay, I think you're right. This is the only thing that matters. Hold on a second. In other words, the rest of it doesn't have anything to do with end behavior.
Right.
So the way I figure it out is I plug in negative infinity to look at the left. That cubes to negative infinity.
Okay.
We still have 2 negatives together. That's positive infinity. So you're right. The left-handed end behavior has to come down from positive infinity.
Right.
And the right-hand end behavior, you do the same thing, only put a plus sign in front of there. And that gives you that, which means it's going down to the right. All right. How about number 2?
It's gonna go. It's gonna be opposite, so it's gonna come up from the left and then go up to the right.
Well, look at that only and do what I did. Plug in negative infinity and then positive infinity. That's the way you figure it out.
Okay, so if you put negative infinity cubed,
Not cubed.
Or no, to the 4th.
Uh-huh.
So that'd be negative infinity? Or no, it'd be positive infinity.
Positive infinity. In other words, negative to the 4th power is positive.
All right.
Negative to an even power is positive.
Right.
Okay? So negative infinity to the 4th becomes positive infinity, so it comes down from the left, from positive infinity.
Yeah.
And what about the right side?
Would it still go up to the right?
Exactly. And this is the feature of quartics.
Okay.
Also, quadratics, notice. Hold on one moment here. In other words, notice that quadratics do the same thing. Quadratic comes down from infinity and goes back up to positive infinity. That's because it's an even power. So even powers always come from the same direction, left hand and right hand end behavior. They don't always come from positive. In other words, it could look something like that. So sometimes they both come from negative. Remember, when you have an even power, they're going to do the same thing on each side.
Right.
All right. Let's see what else they want. Without graphing, find the Y-intercept. Let's go back and look at 1. What's the Y-intercept?
-2.
What's the Y-intercept on 2?
0.
Uh-huh.
Okay.
List the possible number of extremes. And what they mean by that are relative extrema.
Right.
In other words, if I have a graph that looks like this, well, I got a relative extrema right there, I got another one there, I got another one there, and I got another one there. So in that example I just drew, I have 4. Well,
Right.
what's the most you can have on number 1?
2.
On number 2?
3.
All right, you got that. Find actual extremes using your calculator. What kind of calculator do you have?
I have a TI-84, but she said for E and F, we would do those in class because she didn't teach us how to use the calculator, like to find those.
Okay.
She ran out of time, so we just have to go through A through D.
Okay. That's a fairly common thing that you're going to have to do with that calculator. Is this the first year you've used the TI-84?
Yeah.
Okay. Because
Is it the same?
you need to put it in as a function, and then
Right.
you need to graph it, and then you need to request the zeros or the.
Is it the same as finding intercepts on like a quadratic? Because she taught us how to do that, but
It'll
I feel like
give
it'd
you
just
the
be the same.
intercepts on any kind. In other words,
Yeah.
it'll give you the intercepts on that 5th degree equation
Right.
also, which is a good thing because that's nearly impossible to do manually.
Right.
You could spend a better part of a day trying to do that. Good luck. Seriously, those are brutal. Okay, so we won't worry about E and F for the moment then. So let's see, 3, you're going to know, what's the end behavior on 3?
On 3, it'd be up from the left, or it'd come up from the left and then keep going up to the right.
Okay, I'm a little puzzled by your terminology. I think I know what you mean. When you say come up from the left, you mean that.
Yeah.
I would prefer you, I'm not sure what your teacher requests, but when you're talking about end behavior, the best way to talk about it is as x goes to negative infinity, f of x goes to negative infinity.
Okay.
That is extremely specific.
All right.
Up from the left, I guess that is kind of specific. And what's it do on the right?
It increases, so it goes as
x goes to positive infinity, f of x goes to positive infinity also.
Yeah.
And this thing is a 5th degree, so it might actually look something like this. It could have 4, that's 1, 2, 3, 4. It could potentially have 4 relative extrema.
Right.
Now, you haven't gotten to calculus yet, so you don't realize the importance of those, but those are extremely important when you get to calculus. Notice that each one of them you could see has a horizontal tangent line.
Right.
That means a lot. Okay. You're not going to have any trouble with the Y-intercepts on any of these or the possible number of extremes. Do we need to do any others?
No, I think this is pretty straightforward.
Are you comfortable with the end behavior? You want me to ask you another? How about 6? Give me the end behavior on 6.
For 6, the end behavior would so as y approaches 0, x is it's gonna come down from the
actually
left.
The way you want to express end behavior is as x goes to negative infinity.
Okay.
In other words, it's what happens as x goes in that direction. What happens to f of x, which is y?
So as x goes to negative infinity, f of x is going to go up, so to positive infinity?
Correct. That's the way to state it. As x goes
Okay.
to negative infinity, f of x goes to positive infinity. And
Okay.
how about the other side?
As x goes to infinity, f of x is going to go to negative infinity.
That's it. Okay, cool. Let me scroll up here. Oops. How is that? Just a second. I guess I can't scroll. I guess I don't need to. So, write a polynomial function of least degree with the following zeros. I'm trying to think if I need my bigger piece of paper for this one. I might. What do we got? 3, 2, 1 minus 5? Yeah. Let me do that. I think that'll be a little bit better.
Yeah.
3, 2, 1 minus 5. Tell me what the linear factors are.
Um.
There's 4 of them.
So are those the x-intercepts, right?
Correct.
Those are the zeros.
Those
So
are zeros. That means when we multiply all of the linear factors together, we get 0.
okay. So would it just be like 0, 3, 0, 2, 0, 1, 0,
Well,
negative
it's
5?
x minus the 0.
Okay, right.
Was 3. So it's x minus 3 times x minus 2 times x minus 1. What's the last one?
X plus 5.
Now, that's not what they want as an answer.
Right.
They want you to multiply it out.
Okay.
Okay, now the way I think it works best is if you multiply those two and you get a trinomial.
Mm-hmm.
Multiply those two, you get a trinomial. And then the last step is multiplying the trinomial by another trinomial. Okay?
Right.
So, how do you multiply these first two? What's that equal to?
So it'd be x squared minus 3x minus 2x plus 6.
Okay, which is x squared minus 5x plus 6, correct?
Mm-hmm.
Okay. And this one?
X squared minus x plus 5x minus 5.
So it's plus 4x minus 5. And now multiply a trinomial by this trinomial.
All right, so you get x to the 4th minus 5x squared plus 6x squared.
Hold on a second. Let's back up. It's clear to me that you're doing this in a method that is okay. It's not the one I use, but clearly you're doing it like this. You're multiplying that by that, and then you're multiplying that by that,
Mm-hmm.
multiplying that by that. And then next, I assume you're going to multiply that by that and go that route.
Yeah.
I'm not going to argue with you. Are you comfortable with that? That's not the way the way I do it is every term by every term. And so I take that x squared and I multiply it by all three. Get rid of that.
Okay.
Then I go to the minus 5x and I multiply it by all three and get rid of that.
That works.
In other words, I work from left to right, finishing each term before I go to the next.
Right, that makes sense. Right.
Like I said, if you're really comfortable with this technique, it's just as valid, and I don't really want to mess with it. But,
no, we can do your way. It's not. I'm not really comfortable with any like.
Okay. So x squared times x squared is x to the fourth, and then the next one's going to be plus 4x cubed. Keep going.
Mm-hmm. And then it'll be minus 5x squared.
Okay, next.
And then minus 5x cubed.
Okay.
Minus 20x squared. And then plus 10x.
Plus 25x.
25x, sorry.
Multiplying, not adding.
Right.
Keep going.
And then it'd be 6x squared.
Plus, I do need the plus sign.
Yeah, plus 6x squared. Plus 24x. And then minus 35. Or 30.
Okay. Yep. Now, whenever you do these, you're going to notice that this term and this term, there's nothing else like that in there.
Right.
Because there's only one x to the fourth, there's only one constant. So you don't have to worry about combining those. But most everything else can be combined. So how many total of those do we have? There's plus 4x cubed.
We have two of those.
What's the net?
X cubed.
Minus
X cubed.
Okay, and with some of these that have big long strings of polynomials, I actually think it's kind of helpful to mark them off, because then when you're done, you can tell whether you got them all or not.
Right.
How many total x squareds do we have?
3.
Well, I want the coefficient.
What do you mean?
Add those 3 together.
Oh, okay. That'd be negative 19x squared.
Takes care of that one, and that one. And what do we got next?
So 25x and 24x.
Okay.
Is 49x.
Plus 49x.
And 30.
Minus 30. And that's the answer that they were seeking when they asked the question. Okay. And there really isn't an easier way to do it other than this ultra long method. The key to the problem is to take these zeros and translate them into linear factors.
Right.
Okay. Hold on a second. Let me grab a look at the next page. Or the next problem, rather. Minus 3, minus 2, and minus 3i. Minus 3, minus 2, and minus 3i. Is there one they didn't tell us about?
Yep.
What is it?
What?
There is a fourth zero.
Plus 3i?
Uh-huh. They only come in pairs. You will never find a zero of just one imaginary solution.
Right.
If you have a minus 3i, then you must have a plus 3i also. Or if you had a plus 3i, then you had to have a minus 3i.
Right.
So, what are my linear factors?
X plus 3, x plus 2, x plus 3i, x minus 3i.
Now, in this case, doing the imaginaries first, I guess it really doesn't matter. But when you do these imaginaries, you eliminate the imaginary term.
Right.
You end up with just two terms without any imaginaries.
Right.
Nonetheless, we're still going to need to multiply these first two together.
Okay.
In other words, we're going to do it the same way we did the last one.
Right.
So this first term,
X squared plus 5x plus 6.
okay, good. And this, you can do this term by term, but you're going to see that the two middle terms always cancel.
All right.
This is the difference of perfect squares factored.
Right.
So you know how to add it or multiply it back together. It has to be x squared minus 9i squared.
Mm-hmm.
What's minus 9i squared equal to?
Positive 9.
Okay.
So it's x squared plus 9.
Huh? Now we have to multiply these two things together.
Okay.
Now, I don't know. Here we have a trinomial times a binomial. I don't know that it necessarily makes it any easier if you put the binomial in front. Use the same process. And by that I mean start from the left and finish each term before you go to the next term. At least that's the technique. I'd hate to see you start mixing it up because that's kind of a recipe for making mistakes.
Right.
You know what I'm saying? In other words, whatever method you use, stick with it. And if it's the other method, I'm cool with that. Whatever you want to use, stick with it.
Okay.
So what's the answer?
So that's x to the 4th, and then plus 9x squared plus 5x squared, or 5x cubed, and then plus 45x, and then plus 6x squared plus 54.
Okay, keep going.
So then it's x to the 4th, and then plus 5x cubed because there's no other cubes.
Yeah, this is unusual, but that happens every now and then.
Yeah, and then so plus 15x squared, and then plus 99.
Just the 45x.
Oh, right.
Plus 54.
Yeah, so plus 45x plus 54.
Mm-hmm. Yeah. All right. Let's have a look at 0. Write the polynomial function of least degree. 0, minus 2, and 5. What are the three factors?
So it'd be x minus 0.
Which is just x.
Yeah.
One factor.
So x plus 2, x minus 5.
I don't know. I do these however order you want. I'm not sure that one is superior to another.
Yeah. So it'd just be x squared plus 2x and then times x minus 5.
Yeah, I would definitely do it in 2 steps. I definitely wouldn't try to do the whole thing in 1 step.
Yeah.
What do you get here?
So then x cubed minus 5x squared plus 2x squared and then plus or minus 10x. So x cubed minus 3x squared minus 10x.
Okay, good. Minus 1 and root 3.
All right, so it'd be x plus 1, x minus root 3, x plus root 3?
Yeah, and in other words, I was about to get there. Here's another one where they gave you only 2 zeros, but you can figure out a third zero.
Right.
In other words, irrational zeros are like imaginary solutions. They come in pairs. So if I have a plus root 3, I've got to have a minus. And the way to kind of memorize or remember that is if you think of the quadratic formula, it's minus b plus or minus the square root of something over 2a.
Right.
So whatever number this ends up being, you always have that plus and minus there.
Right.
And for the same reason that if that ends up being imaginary, you end up with a plus and a minus imaginary.
Right.
So, and this is going to unfold a lot like imaginary numbers do, in that because one of these is the conjugate of the other, when you multiply them together, the two middle terms cancel one another out. You can kind of see that the O and the I cancel one another out.
Yeah.
So what's left?
So x squared,
Think difference of squares.
yeah. So
it's always
x squared minus 3.
Minus 3, exactly.
Yeah.
Okay. Times x plus 1.
Yeah.
Now, as long as we're talking about it, let's talk about difference of perfect squares. They don't need to be perfect squares.
Right.
They just need to be numbers. I can factor if I want. If I had x minus 7, I can factor that into the square root of x minus the square root of 7 times the square root of x plus the square root of 7.
Right.
So I imagine it's for education purposes only that they start off teaching this as difference of perfect squares.
Yeah.
In other words, you only learn it when you're dealing with perfect squares. But the reality is that you can factor any binomial or linear term
Right.
by just using square roots. Now multiply that binomial by that one.
So you get x cubed minus 3x plus x squared minus 3.
Yeah, and the only thing you maybe need to do is put it in order.
Yeah.
According to the degree of the term.
Yeah.
All right. On number 11, what are the other 2 zeros?
2 minus 2i and negative root 6.
Okay, so there's 4 total zeros, so you're going to have 4 linear terms.
Right.
And we should at least, I don't need to draw it out. I don't know that we want to, I feel like you know how to do these pretty good, this multiplication. So
Yeah.
we don't really need to spend all of our time doing it.
Yeah.
Notice that when I do the linear terms on this one, I have x minus, and you can put an extra set of parentheses in there if you want,
Right.
but it turns out that if you don't put the parentheses in there, it's just the same thing.
Yeah.
In other words, here,
Isn't it 2 minus 2i on one of those?
no, well, not yet it isn't.
Okay.
In other words, what it is x minus that, which is what that is,
Right.
and x minus the conjugate. Okay, that's what you meant, and you're correct. Absolutely. That is a minus right there. And effectively, conceptually, I need those inside parentheses.
Right.
Hold on a second. Just a second. I'll get this right yet. That's a minus also. That's why you were confused, because I wasn't doing it right. In other words, we have x minus one of the solutions and x minus the other imaginary solution. But when I remove the inside parentheses, it looks like I'm just doing this,
Right.
which is what somebody would put if they didn't use the inside parentheses.
Right.
In other words, that's one of the solutions, that's the other solution. And they're both being subtracted. But technically, I always like using the inside parentheses so that I just won't get mixed up.
Right.
Even though I used them and I did get mixed up. But nonetheless, this you could write it directly like this, I suppose,
Yeah.
without using the inside parentheses. So other than that, this doesn't give you any problem, does it?
No.
Again, when you multiply these, everything with I in it is going to disappear. Or turn it into an I squared. And the I squared
which is just negative
are real numbers. Yeah, those are not imaginary numbers anymore. Once you get I squared, that's -1. All right. Let's go on, and if we have time and are looking for stuff to do, then we can come back and finish some of these that we may not get to.
Yeah.
Let's see, the fractions.
It's the same thing, just with fractions. So
Tell me what the linear factors on 12 are. We don't necessarily have to do the multiplication.
It'd be x plus 1/4, x minus 1/4, and then x minus 1/2.
Yeah. All right. And I feel like you know how to multiply those out.
Right. Yeah, it's just fractions.
So let's do something different, like 14.
All right.
2 with multiplicity of 3. In other words, there's only one 0.
Right.
But it has a multiplicity of 3. What does that tell me about the factors?
So wouldn't it just be like x minus 2, x minus 2, x minus 2?
Oh, Or I could write x minus 2 cubed.
Yeah.
But since they want the polynomial, we would want to multiply that out.
Right.
And again, you can just multiply that by that. You'll get a trinomial, and then multiply that trinomial by that binomial.
Yeah.
And you'll get a third degree 4-term polynomial.
Yeah.
So whenever you have a multiplicity, if it's not listed, it's always 1. In other words, everything else we've done here has been multiplicity of 1. So how about 15?
So 15 would be, the factors would be x minus 3, x minus 3, x plus 5.
Good. Okay. Is that the bottom of that page?
Yeah, that's the only homework I had. It was pretty simple.
Okay. Any other questions? Did we?
I mean, not really. This was a pretty
everything on this page
simple unit.
except actually came up with the answers, and I really feel like that you can do that without my help.
Yeah, those are pretty self-explanatory. It's just multiplication.
Just make a brief mention of multiplicity. This is going to be worth knowing before I let you go.
Okay.
If I'm graphing an odd multiplicity, my 0 is at 2, right?
Mm-hmm.
So the graph is going to cross through. It's either going to go from positive to negative or negative to positive, but it's going to cross through the x-axis whenever I have odd multiplicity.
Yeah.
When I have even multiplicity like that, it kisses the axis only.
Okay, so it's like a single answer.
Well, it does like this. In other words, if my 0 is at 3, then it's going to come down, and instead of going through, it's going to bounce back up and go up.
Right.
And then it'll go through at -5 because that is single multiplicity. So whenever multiplicity is odd, it passes through the x-axis. And whenever multiplicity is even, whether it's 2, 4, 6, or 8, doesn't matter, it bounces off the x-axis.
Right, that makes sense.
That's why if you look at the standard quadratic y equals x squared, that's even multiplicity. The zeros are 0, but it's a multiplicity of 2, and therefore it goes down, hits that, and goes back up.
Okay.
I can't think of anything else interesting to say.
Yeah, no. Yeah, sorry, this is just a short unit.
I will let you go.
Great. All right.
And let's see, we're going to meet Wednesday night also?
Yeah.
Okay, sounds good. Talk to you then.
Cool. Awesome. Thank you. Bye.